clear as well.
Okay, perfect. Thank you. Okay, so a little bit more on security. We're going to discuss 10 things that you need to do to build rock solid Azure tenant. Let me quickly introduce myself. So I'm Mustafa Toroman. I work as a solution architect at the company Authority Partners. Last few years, I've been engaged with a lot of enterprise US companies, primarily from fintech, and you can probably imagine that security for those kind of companies are a big thing. And also in convincing those kind of companies to move to the cloud and that it's secure enough is very challenging, but we kind of succeed on that. So I've been also a Microsoft Azure MVP, just received my 5th award in a row a few days ago. Also very certified in different Microsoft technologies, have over 50 different active certificates right now. Will not lose time to just count them. It will take too much of our session. So before we start addressing things about security and cloud, we need to understand few things. We need to address certain points that will help us move to cloud and keep everything tight and under control. So there are a lot of different areas when it comes to cloud security. So first part is that when we look at the Azure data center, so the data center where our data is going to be once we decide to start our cloud journey, or in this fact, Azure's journey, first it comes to physical security. So when it comes to physical security, I think this is the probably best you can get. Everything basically around Azure data center is state of the art and latest industry standards. Basically, when physical security comes to point, like there are several perimeters that you need to pass just to enter the building where everything is stored. Then everything is under cameras and alarms, 24/7 security staff. There are barriers, fencing. Basically, each security point must be bypassed by two-factor access control. There are also, when it comes to security, there are days of backup power that even if something goes wrong, can keep up security system up and running for days to come. So basically, everything is secured by design, and we have a lot of options. And like most of the companies will have a really hard time maintaining such tight physical security because it costs a lot of money and dedicated resources to build that sort of thing. Then after that part, we have infrastructure. Infrastructure is another part that's is controlled by Microsoft completely. So we have completely secure infrastructure. Again, latest security standards, industry compliance, everything is taken into account. And this is also the part that Microsoft controls completely. So physical and infrastructure are something that Microsoft is maintaining and keeping itself responsible. Now we are coming to a network part that things kind of start to divide. On the network stack, when it comes to the physical network, in fact, Microsoft is again responsible for applying security standards and keeping everything tight. But here comes certain things like public access, virtual network control, and those sort of things that are completely under our own control. And this is where we need to look at the things we are managing and how we can manage them. And then we come to virtual machines and applications and that sort of thing, where we have more control over how things are secure and how they are set up. So it's really important to understand this concept because, as I said, it's especially in like, I don't know, like 4 or 5 years ago, it was really hard to convince customers that cloud is secure, because they are used to different setup. They are used to having their applications and data stored in their data center, between in their physical building, where they can actually see them, like just open the door and see where is everything stored. This is kind of different concept. It was hard to convince people that is secure enough, and there was a lot of sales pitch that is telling people like, oh, yeah, it's really secure, just go there, it's more secure than you have it right now. It's true, but to a certain extent, because putting data in Azure usually makes it more secure, but it's also what we do with it afterwards. It's also very important, and something that we need to understand, that just by putting it to cloud, any cloud in that fact, Azure is just an example we're using here, but all other cloud providers are doing the same. So basically just putting in there doesn't make it completely secure. It has a certain standard, security standard. It is, some parts of it are more secure than you could probably ever achieve it, unless you're like a government or military or something. But for the majority of the companies, it's more secure when it comes to physical infrastructure part. But here comes this part where we have need to introduce this shared responsibility concept, and the things that we are controlling and what is cloud provider controlling. So it also depends on the type of services that you are using. For example, for software as a service, cloud provider is controlling majority of security things. When it comes to platform as a service, we control a little bit more. And then with the infrastructure infrastructure as a service, we control a bit more, especially when it comes to the network controls, operating system, and so on. So it's really important to understand that just by putting it in the cloud, it's not 100% secure. We still have some kind of responsibility, and we need to take care of certain things. So basically, just for an example, like if we create a endpoint for the data access, and we just open it like completely anonymous, like anyone can access it without any kind of authentication or whatever. This is not something Microsoft can address out of air. Like, it's something that we need to take care of. We have to provide some kind of security model, some kind of process that will verify who is accessing the data. Also, when it comes, for example, if you create application and application is vulnerable to SQL injection, for example, which is unfortunately still very high case for web applications, Microsoft cannot be responsible for our bad code. Now, for both cases, for both data access and for SQL injections, Microsoft is providing us tools that we can use to tighten it a bit, but we still need to address those things and decide how we're going to use it and when. So when it comes to security, I could probably go on for days. Each of those points, like the things we mentioned, physical infrastructure, network, virtual machines, applications, I could spend whole day talking about each of them. But for this session, we're going to concentrate on 10 easy wins. We're going to concentrate on 10 things that we can actually go out there and do for ourselves right now. So 10 things that are going to make a difference, and you can do them right after the session. So we're going to provide 10 easy wins to increase the security. So first thing that we need to set up is MFA. So it's a really important thing when it comes to cloud security. Handling identity is much different than handling the same thing in on-prem environment. So in case of any kind of credential leak or something, in majority cases when we have on-prem environment, it's still not complete disaster, because whoever gained the access to credentials, a bad actor that gained them, it doesn't really matter how, but gain the access to the credentials, won't misuse them, they still need access to our physical network. With cloud services, it's much different. With cloud services, we have actually to consider that these are public services. These are services that are accessible for virtually anywhere in the world. So we need additional layers. So credentials are not enough anymore. So how does it actually like work? Really simple. Let me just like switch to different. I'm gonna do like, one second. Okay, not this one, but too many windows open. We're gonna use this one. No, this is my presentation. Then I'm just gonna share my screen completely, and then we're gonna go for there. So I'm gonna share desktop. Tell me you can see my browser now, hopefully. Okay, so when I provide my credentials, I'm gonna like probably it's gonna ask me for a password, which is completely fine, which I hope I remember. No, it wasn't that. Or this one. And then there's a second step of validation. So I need to verify that this is me actually. Most usual way to do it, and the way I did it right now, is by a mobile phone. But it can be a variety of different things. So we can use biometrics, we can use security keys, hardware tokens, and so on. But it's really important to add this additional verification when it comes to account. It's really easy, and in like 95% of data breaches and any kind of security issues in general, it was up to leaked credentials. Was it like a phishing attack, social engineering, or something else? But majority of cases are those kind of things where where user does something wrong, gets hooked, and someone else gains access to it, to his or her account. So basically, just by providing this simple feature, additional check, we are increasing the security by a big percentage. This kind of there's still ways to bypass MFA, but it takes a serious skills and serious equipment and serious time to spend. And again, it's very important to remember that when it comes to security, there's no such thing as 100% secure system. Whatever you do, there's always a way that someone can do it. But it's a matter of balance between what we want to achieve. So how much time and money we will spend into security to make it secure enough, just to make it basically unuseful for someone to target us. So basically, any system can be hacked, but if it takes like $2 million and 5 years to break it, does it really pay off to do it? So basically, we need to do that balance and invest in security in that amount that we are not interesting for everyone. It doesn't pay off to do it. So best way and easiest way we can do it right now is by using mobile phone. Everyone is using one, and everyone is walking around with mobile phone everywhere. Mobile phone is with us no matter if we are like at lunch, in bathroom, sleeping. It's next to our bed. Whatever we do, mobile phone is always with us, and mobile phone supports variety of different options as well. We can do like text message. We can do a phone call during which we need to provide some kind of PIN, or it can be an app. App is really simple and easy to use. Just sends a push notification that you need to approve that you are actually the one trying to do sign in right now. Okay, so let's move on. Okay, before we move on, okay, so MFA is really good, but one thing that when we are like discussing access and signing process, something that we also might consider is using going totally passwordless, because it proved to be a really good concept. It relies on zero trust approach and using passwordless sign-in that actually uses a security key, simple USB that can be used to verify your access. It can be also a really good option. Unfortunately, when it comes to Azure, this thing is still in preview and it's not available as a default sign-in option, but it's something to look into and something that is definitely going to be a future for identity when it comes to cloud. Okay, next thing that we need to consider is using role-based access controls. Managing Azure and Azure services is quite different than managing on-prem resources. And I don't know if any of you remember back in the day when Azure just started, it uses quite different portal, and it uses something referred to now as Azure Standard model. Like 5 years ago or 6, I kind of lose track right now. We got introduced Azure Resource Model, and this brought big changes to the picture, especially when it comes to security and management. So back in the old days with the old portal, we basically had only 2 roles when it comes to management. It was admin and co-admin. So basically, admin was the person who created the subscription, and co-admin was anyone else added. And this level of access was only on the subscription level. So if I wanted to provide access to single resource, like single database, single virtual machine, single application, whatever, to any of you right now in my own subscription, the only way to actually do it was to provide access, and this was co-admin access to complete subscription. And the only difference between admin and co-admin back in the day was that co-admin couldn't remove admin. That was basically it. Co-admin could do anything else: delete resources, add new resources, cancel the subscription even. Everything was open. So Azure Resource Model brought a lot of changes. It introduced also resource groups, which represent logical containers that we can like use to place resources in a certain way. It can be a majority of options, like based on life cycle, based on resource type, based on application type, and so on. But role-based access controls gave us a more granular option to provide access. So basically, let's see how it looks like. So if I go to my subscriptions, I can go, for example, to this one. I have access control over here. And right now I can see who is assigned with the access and what kind of access do they have. But let's say I want to add a new role. I want to do a new role assignment. And let's say I have a bunch of predefined roles right here. So basically a bunch of different roles that I can use. It introduces, beside the owner that could basically do anything, we have a contributor, reader. There are a lot of different roles based on the resource type. So for each of the resources in Azure, we have kind of different roles defined. But let's say I'm just going to do like a reader right now. I can assign it to a certain account. I can say I want this one, save, and this account has now, okay, this account already has a different role, so it failed. But this is the way I can provide a different type of roles to different users. And also, it's very important to remember that this is not only on subscription level now. I can go to any of the resource groups and do the same. So basically, any of the resource groups, I have access control again, and I can assign access to this specific resource group only. And if this person signed into Azure portal, A person wouldn't see everything in subscription. A person would see only this specific resource group and would have access only to it. And we can even go deeper and say, okay, I don't want access to the subscription to the resource group either. I want this person to have access only to this specific resource, and I can assign access only to this specific resource. So it's really granular, and we can like decide what kind of level access we want, and also decide what kind of role we want. So basically, a lot of different predefined. It's also important to mention. Okay, let me just switch here. That we can add a new custom roles as well here. So we can design our own roles and set up the permissions that we specifically want. They are kind of different from what is already predefined in Azure Portal folders. Okay, so let's move on. So another thing that I really like about cloud is relatively easy privileged identity management. And this part is one of the concepts I really like when it comes to security. So this is there are really two concepts that I always look into when we discuss security. One is just in time access, and other one is just enough access. So we need to keep those in mind when we discuss security very much. So just enough access is that we are not providing user with more access than user actually needs. And just in time access is a process, is a concept where user gains access when needed, not by default. So privileged identity management is something that addresses exactly both those issues, and it gives us an option to assign user with a certain elevated permissions, but those permissions are not actually active by default. So basically, when it comes, for example, if there's a credential breach and someone gains access to account, by default, when the bad actor uses this account and logs in, it doesn't have actually any kind of elevated privileges. It doesn't have any kind of elevated access. It's not an admin for anything. It cannot change anything, and so on. By privileged identity management, we have option to set this kind of access to be activated once user actually need it. So basically, when we log in, we have access to our usual stuff like email, I don't know, Office 365, some kind of application that we are daily using, and so on. But for the elevated access, we actually have to go to a certain portal and then activate our role for a certain amount of time. Now, there are two concepts that we can use there. A user can either just activate it by itself, but also we can set monitoring over that. So a manager or someone else can actually approve the activation, and then we have another security layer incorporated that. So basically, this provides us with this concept that user doesn't have more privileges than needed, and also the privilege is activated only and just when user actually is going to perform certain rules, not by just logging into to user account. This also provides us with a lot of different metrics and information, because it can tell us how much users are actually using their roles. So for example, someone might be like a security administrator, but didn't use that role for over a year. That clearly tells us that this user has certain privileges that are not needed for daily job, and something that can be addressed and changed when we do audits of such reports and so on. Okay. Next, we move to network security groups. This is the first layer of network controls when it comes to Azure. So let me pop up to Azure portal. By default, we don't have much, like network security groups are the default option for our security. And when we go to networking stack for our virtual machine, we can see all the rules and things that are applied. So network security groups act kind of as a Azure, like access control list, or basically a simple firewall that can we can decide which kind of protocols and which kind of ports are open and what kind of traffic and flow. We can, like, for example, we can do, here we see inbound port rules, and we can see that default rules are that it allows virtual network inbound traffic, Azure load balancer inbound traffic, and in this particular case, it's HTTPS is also open. So these three options are allowed, and we can see also exclamation mark that this is not a default rule. This is a custom-made rule by someone else. These two are there by default. When it comes to outbound, basically by default everything is open. Any kind of traffic is, so it allows traffic to virtual network, to internet, and denies anything else. But we can add inbound and outbound rules. It's very important to consider the priority. The lower the number, it represents the higher priority. So 100 has a higher priority than 110, 110, but then 200, and so on and so on. So basically, it's something that you need to keep in mind. Also, keep in mind that network security groups can be assigned directly to virtual machines, to network interface cards, or they can be assigned to virtual network, subnets. I suggest to use the second one, to go with the subnet option, because it will make your life much easier than handling everything on the next level. Why? Because, okay, it's perfectly fine when we have 5, 10, 15 virtual machines, we can still track the rules and see how the traffic flows. But when it comes to like hundreds or thousands of virtual machines, it's really hard to keep track of all the rules and everything if they are assigned on the virtual machine level. So it's much better to design virtual networks in Azure, to have subnets that address specific use cases. For example, let's just take example that we have a simple three-tier architecture for the application. So we would have some kind of front-end web access tier, we would have an app tier, and we would have a database tier. And in this case, like, we would allow public access to the first one, to the front end, where we have some kind of web servers. Second one the app level would not be accessible over the internet, but would allow any kind of access coming from the front tier. And database tier would not accept any kind of connection coming from internet or the front tier directly, but only things that are connections that are coming from the up tier. Okay, so let's move on to the next one. So, oh yeah, one thing that we also need to consider when it comes to these kind of sort of things, these are the basic built-in options. For more things, we can use, for example, Azure Firewall, that will give us much more detail and better control. And optionally, we can also use different kind of virtual appliances. So basically, most of the network security industry leaders are present in Azure, and you can just like spin up a virtual machine containing that virtual appliance. For example, like their Palo Alto, Cisco, F5, I don't know, Checkpoint, you name the security company that makes firewalls, they will be present in Azure as well. And you can, like, if you're accustomed to it, if you trust that manufacturer, you can just transfer that to Azure as well, and keep using that option too. Okay, next thing is web application firewall. Web application firewall is an advanced option coming along with the application gateway. And this option allows us to significantly increase security for our web applications. Why? Because it can detect what kind of traffic is coming in and prevent any invalid and bad intent request coming and stop it before reaching the application itself. So I already mentioned that Microsoft cannot be responsible for bad code that we have, but web application firewall is one of those examples where Microsoft provided things that we can actually use to prevent such things. So, for example, application gateway can stop SQL injection. It will detect such bad requests and stop such a request before actually reaching our web application itself. It will, of course, provide any valid request and pass it through to its destination. But any kind of bad ones like SQL injection or cross-site script attack or something else that is accustomed to web application can be prevented with such an option. Okay. One of my favorite things in Azure, one of my favorite services or tools or whatever is definitely Azure KeyVault. Azure KeyVault provides us with ability to manage sensitive information in Azure. So it can be used to store different kind of secrets, passwords, and certificates. Also to be used as a connection string along with the infrastructure as a code and so on. So why is this important? So basically, again, we are moving things out of our local data center. A lot of things are accessible from internet. A lot of things are visible to a lot of different people, and we need to keep certain sensitive information in check. So basically, when we have a secret password certificate, we can securely store them in the key vault and provide people with the ability to access those without actually knowing the content, the value of those. So basically, same things goes with the connection string because it falls into all these categories about it. It's a secret and the password itself. So basically, if we have a developer that needs certain accesses, for example, to the database and needs a certain connection string, we can provide access from the key vault, and application can get the access to the database itself using the connection string stored inside the key vault. But developer doesn't really need to know the value of these, either where the database is or what are the credentials for the database, and can securely use it without actually knowing the values that are in the background. Similar thing can be applied for infrastructure as code. So if you started your cloud journey, infrastructure is something that we look a little bit different on in cloud and should be treated as code. But using infrastructure as a code has certain challenges as well. So basically, if we look at most of the services, like during the deployment, we're going to need to provide certain password or something. So if we keep it as an infrastructure as a code, it's really a bad idea to keep those passwords in code itself, because a lot of people can stumble upon the code. Also, it's been very often in the last few years that someone accidentally submitted such things like infrastructure as a code things in public repositories, and everyone suddenly had access to certain resources and so on. So to avoid these kind of things, we actually would probably want to keep secrets and passwords stored in KeyVault, and during our deployment, just kind of call the KeyVault to provide the value without ever exposing it publicly. this also comes in handy when we have a team of people that is going to do the infrastructure deployments, but doesn't necessarily need access to certain resources. So just because, for example, just because I'm deploying new database, it doesn't really mean that I'm going to use that database and I'm going to need access to that database. I don't need to know the username and password, just like I'm asked for a certain department, for a certain team to create that database. I created the KeyVault. The KeyVault provides information about all the sensitive information, and the team can get them from kind of different sources, either from KeyVault or someone managing the KeyVault. But I, as a guy that deploying, doesn't really need to know those values. So that's also very interesting. Another thing that we need to discuss when it comes to cloud is data encryption. Now, to be honest, data is encrypted by default at rest. So if it doesn't really concern us on a certain level, it's probably good enough. So everything inside Azure Data Center is encrypted at rest, and all our data is encrypted at rest. If someone with all the security measures managed to get into the Azure Data Center and pulled out the disk from the rack that our data is stored on, that person couldn't do much with it. It's encrypted, and to break that kind of encryption takes a lot of time. So basically, if that part is good enough, it can be, but based on certain things like certain compliance models and security standards, we need to address this separately and cannot rely only with Microsoft managed keys, Microsoft encryption. And we can use, again, KeyVault, really cool feature, one of my favorites. We can use KeyVault to actually use to encrypt our own data. So how this actually works. So let's quickly look into any kind of, so let's, for example, the simplest data in Azure is definitely a storage account. So if I go to, I don't know, any kind of storage account, one of the things that we have here is encryption. So by default, okay, this is not a good example because this one is already using it. Let me switch to a different one. This one too. Come on. Okay, here it is. So by default, and you can see it from the message, you can see that this is definitely encrypted, and it's encrypted with Microsoft managed keys. Now, this is important to understand what happens here. So basically everything is encrypted at rest, but any kind of like backup, data export, and so on will be unencrypted. Why? Because, okay, so if we want to download our data and use it for something else, we cannot get that data in encrypted state because it's encrypted with Microsoft managed keys. We don't have those keys. So once we would download that kind of encrypted data, it wouldn't mean anything to us because it's encrypted and we still cannot use it. So basically, anything that is encrypted with Microsoft managed keys is going to be encrypted once it leaves the data center. So in these cases, if we want to keep the data encrypted, we must use our own keys. And it's really simple to set up. So basically, if I want to use my own key, I have an option to provide here. I can select the KeyVault, say in which subscription, I can say which KeyVault I want to use, and I can say which secret I want to use. And that's basically it. This is done. I'm done, and this storage account will be encrypted with my own keys. Similar thing can be done with a bunch of services. So basically, if I go to, for example, I don't know, let's go to a virtual machine, and if I go to a virtual machine, let me check this on this one. This one is. Okay, this is this. Okay, this is good. So this one is, so again, you can see that it is encrypted, but with Microsoft keys. So if I go to this one, to the disk, I have encryption options here. Okay, this is, okay, my bad. This one is, let's see this one. Okay, this is the good one. There's different things with premium disks compared to this one. So let's see. So I have a disk and it is encrypted with Microsoft keys. And if I go to the encryption level again, oh, I know what's wrong. Never mind. The problem with this is that it actually virtual machine is not running. Never mind. Let's see if this one can be done then. Let's see. Let's see. Hopefully this one will be. Oh, never mind. Went to the wrong direction. Never mind. Let's move on to a different service. I was not. I recently deleted some virtual machines that I shouldn't delete, and this is the result of it. Okay, so it can be applied to virtual machines as well. Trust me on that. Just because I don't have them created correctly right now, it's on me. A similar thing can be done with the databases. So by default, if you go to database and see the transparent data encryption, by default it's set to on. Now this provides, if anyone ever set up TDE on the local environment on the SQL server, it's a tedious process. You have to set up the master encryption key, then server encryption key, then encrypt database with the separate keys, and so on and so on. And to actually, if you want to restore the database somewhere else, it takes a lot of time again. We need to restore complete chain on the secondary server from the key encrypting the database to the server to the master encryption key, and so on. So it's a really hard to set up, and even harder when things are wrong. In case of Azure SQL databases, it's just things of on and off. Now this one is actually using Microsoft provided keys because it's set already on, and by default this is set on. For the older databases, older than I think 16, 17 months, this setting is set on off, and you have to turn it on. To actually encrypt it with my custom key, I would need to set it to off, and then wait for the decryption process to stop, and then encrypt it again with my own keys. Okay, let's move on to the next thing. Okay, one of the really cool things in Azure is definitely Azure Security Center. Basically, this is the place that can provide you with a lot of information on what is your current security and how good your security posture is in general. So let's take a look at that one as well. So basically, if I go to Security Center, there are literally different hundreds of different dashboards that we can look and check on, and so on and so on. So we can see here our over security score telling us what is good, what needs to be done, and so on. It's also, this is the general dashboard, but we can also go to recommendations on different types of services level that will give us a little bit more details on the things. For example, if we go to the recommendation, we can see that MFA is not enabled on all accounts. We can also see that there are vulnerabilities that need to be remediated. We can see that management ports are not secure everywhere. So we can see that access and permission is not completely covered. They are different kind of things. So it's also really cool that we can see that we can, for example, we can see that for remedy vulnerabilities, we have different things, and for some of those, we have an option for the quick fix. And these are literally the ones that you can just like select and run the remedy, and it's done. So basically, these are things that you can get automated. For some other ones, you can actually go and see what are the issues and can be provided with the more information along with the remediation step and what needs to be actually done to address those issues. It's also very important that this can be used to track different progress when it comes to regulatory compliance. So if you're looking into and you're required to have a different regulatory compliances, you can check what is your progress currently here. For example, in Europe, ISO 27001 is a really big thing, and you can see your current situation and what needs to be addressed on your resources to actually satisfy all requirements by this standard. For US, for example, SOC is really important and popular, and you can also go there and see actually what are the issues and what needs to be addressed on your Azure resources to actually address them and comply with the standard. Oh, there's a message here. Okay, it's not mine. Okay, let's move on. One of the really cool things connected to Azure Security Center is just-in-time access. And this is one of my favorite things in Azure Security Center, definitely. Azure Security Center provides a lot of good information and easy fixes for you and things how you can like increase your security. But just-in-time access is definitely one of the coolest ones. Why? Okay, so first thing, just-in-time access for virtual machines is one of the concepts that I really like. I already mentioned the just-in-time access, but it also addresses different issues that we might have with our virtual machines. For example, when it comes to management of virtual machines in Azure, it's really not a good idea to have any kind of management port open locally, publicly, sorry, because it will attract a lot of unwanted attention. So basically, if you want to manage our virtual machines, it doesn't really matter if it's PowerShell, or RDP, SSH, whatever protocol you're using. It's really better to have either like any kind of VPN, site-to-site, point-to-site even, or have I don't know, like set up a different kind of. There are additional services now that can be used for that as well. But having opened them publicly and access them over internet is really, really bad idea. Why? Okay, so basically I did a little test. I created blank for virtual machines, nothing specific on them, like nothing interesting whatsoever, like nothing. Blank Windows Server 2019 virtual machines. Only interesting thing about them was that RDP port was open. It was open over internet. They can be accessed over internet, all four of them. So I left them there and monitored what is going to happen. So in a single month, each of those virtual machines got brute force attacked over 40,000 times, totaling for those four virtual machines almost 200,000 brute force attacks in a single month. What happens? Like bad guys are going to like scan the public IP address range and look for any kind of ports. If they see the management port open, they're going to start hitting it. And this is exactly what happened. So the good thing about it was that when you look through the logs and see who tried to log in, a lot of them are using like admin, administrator, sysadmin, root, and those sort of things. Hacking tools, more brute force tools are using dictionaries to provide attempts, and those are most used usernames like admin, sysadmin, and so on. A good thing about it is that Microsoft actually doesn't allow you to create such username. You're not allowed to use sysadmin, admin, and so on. Those are the reserved words that are not allowed. But also, it's not. It tells us a lot that we really don't want those kind of things happening, and we don't want to provide them with a chance to reach our virtual machines. So how actually this works? So if I go to just-in-time access, I have non-configured ones. Okay, so it's telling me that I have a couple of virtual machines that have kind of high severity and can be accessed over internet. So what I need to do now is I want to enable it on this virtual machine. I want to say, okay, on this virtual machine, I want to enable just-in-time access and set it up. So I know that this virtual machine is a Windows virtual machine, so SSH is not an option for me. I don't use it right now. Okay, let's leave both RDP and PowerShell good. So what I can do also is adjust this a little bit. So this port, so this is RDP. I can say what is the maximum amount of time the access can be requested. I'm going to drop down to 2 hours. I'm going to do same thing for the PowerShell ones, WinRM to be exact. But okay, this is what it's used for now, and I enable it, and this is done. Now, what will happen on this specific virtual machine? If I go to this virtual machine, just give me 1 second. So this was this one, okay. If I go to this virtual machine and look at the networking, I can see that there are, like, my RDP was there, and I can see that there's additional security rule that was created, and we can see that it uses JET rule. It's security center JET rule. So right now, these rules will prevent me from accessing it by default. So basically, if I wanted to... Okay. So if I wanted to connect to this virtual machine, I wouldn't be able anymore, because new rules are created to actually stop me from accessing it over internet. If I wanted to access my virtual machine now, I would need to go to my just-in-time access and select this virtual machine, say request access, and then I need to activate it. I can say, okay, I want my RDP done. I can select it from to be either from my current IP. It will detect my current IP automatically and add it to the rule, or I can do a custom range, IP range, and I can say if it's going to be for an hour or 2. And when I do it, this will open the ports for me, and now I can actually access that virtual machine. It's limited to access from my specific IP address, and it's limited for a certain amount of time. So basically, even people working in my company or whatever are not able to access it all the time. They are limited. They might be able to squeeze in for the amount of time that I'm using it, but it's going to be still in much better control. Okay, let's move on. Last thing that I want to mention when it comes to Azure security is definitely Azure Sentinel. So there was a lot of confusion with Azure Sentinel and Azure Security Center, what does one do, what does the second do, and so on. So it's really important to separate those concepts. Now, Azure Security Center is something that is there to monitor your current security posture and basically compare it to the baseline. It's providing you recommendation based on best practices and a few past incidents. Now, and it's all there is to increase the security to a certain level. It's not there to actually stop bad things from happening. It's just there to increase the security. Now, Azure Sentinel is completely different tool that is used to monitor live events in your Azure subscription, and is there to use machine learning and different algorithms to track down incidents, connect them, tie them together, and give you opportunity to respond before they actually make any kind of damage. So it's basically there to stop the attacks and detect them in real time. Detect that something bad is going on with your Azure resources, that they are under some kind of stress, and that there are certain things that you need to address right now, that bad things are going on right now. It's also the importance of this tool gives us, like, when we look at the past, and like when we analyze the security issues and system hacks, bad actor usually gains access to our system 9 months before we actually detect it. So we usually investigate those things and try to figure out what went wrong only when things are already wrong. So we know that we were hacked. We know that our data was leaked or something else. So basically, this is when we start to investigate and try to figure out what went wrong. Azure Sentinel is there to provide us the chance to be proactive, to actually try to prevent anything from becoming a security issue, and even if it's a security issue, if it's already a breach, to detect it as soon as possible and try to minimize the damage. Okay, do we have any kind of questions?
No, we don't have any questions at this stage. We got 3 minutes, so I'd like to request, like, if you have any question, please feel free to put it into chat window, and we will be happy to answer it. It was really good session, Mustafa. This is like definitely very interesting, and like, you know, it shows how Azure makes life so easy compared to what we used to do, like, you know, setting up all the encryption, setting up all the security, monitoring, and, like, you know, comparison between, like, you know, what used to do in CapEx and now what OpEx can supply with the, like, you know, it's going to be best for not only the, like, you know, the management people, but for the technology people as well now.
Yeah,
So
it's there to make us our lives a lot of easier. It's there to provide us with tools and like for example, I mentioned the transfer data encryption. Like, it takes you 2 days to set up complete chain and configure everything. This is out of the box, just one click and you're done. It gives you time to concentrate on other things, like important things that we like. It's there to help us, not only for the business, but for the technology people as well. True.
tech people as well. Yeah, absolutely. So really good session, Mustafa, and really appreciate the time today.
Thank you everyone for your time and your attention.
Thank you very much. Before we move on to next session, let me just reconfirm